Hello everyone, I'm Sarishna Manohar from CSCB presenting my tech talk on probability and statistics. The topic I've chosen is random variables and probability distributions. Let's begin. Let's start with the first chapter or the first main heading, random variables. A random variable is a key concept in probability theory and statistics that formalizes the notion of uncertain and unpredictable quantities. It represents a numerical outcome or value that is determined by a random or chance process. In simpler terms, a random variable is a variable whose value is determined by the outcome of a random event. The definition of a random variable. A random variable is a variable that takes a different numerical values based on the outcome of a random event or experiment. It assigns a numerical value to each outcome of the event or experiment. Random variables can represent various quantities, such as the number of heads obtained when flipping a coin or the temperature recorded at a specific time. More formally, a random variable is defined as a function that assigns a real number to each possible outcome of a random experiment. The set of all possible outcomes is called a sample space, and the random variable maps each outcome to a specific value. These are two main types of random variables, discrete random variables and continuous random variables. Let's begin with discrete random variables. Discrete random variables are a type of random variables that take on a countable set of distinct values. They are associated with a random experiment or events. When the outcomes can be listed or enumerated, the values of discrete random variables are typically whole numbers or integers, although they can also include fractions or decimals in some cases. Key characteristics and properties of discrete random variables. Countable outcomes. Discrete random variables are defined by a finite or countably infinite set of possible outcomes. For example, the number of children in a family, the number of cars passing through an intersection in a given time interval, or number of heads obtained when flipping a coin multiple times. Probability mass function. The behavior of a discrete random variable is described by its probability mass function. The PMF assigns probabilities to each possible values that the random variable can take and specifies the probability of observing a particular value or outcome. The sum of probabilities over all possible values is equal to 1. Probability distribution. The probability distribution of a discrete random variable is a complete set of probabilities associated with each possible outcome. It provides a summary of the likelihoods of different values occurring. It can be represented graphically using probability histogram or a probability mass function plot. Expected value. The expected value or mean of a discrete random variable represents the average value it would take if the random variable experiment were repeated many times. It is calculated by summing the product of each value and the corresponding probability. The expected value provides a measure of central tendency for the random variable. Variance and standard deviation. Variance measures or variability of a discrete random variable around its expected value is calculated as the sum of squared differences between each value and the expected value, weighted by their probabilities. The standard deviation is the square root of variance that provides a measure of dispersion. Let's conclude with discrete random variables. Discrete random variables are widely used in various fields, including probability theory, statistics, and decision analysis. They provide a way of model and analyze discrete phenomena such as counting events, occurrences, or frequencies. By studying the properties of discrete random variables, statisticians can make predictions, estimate probabilities, and make informed decisions based on underlying probability distribution. Let's move on with continuous random variables. Continuous random variables are type of variable that can take only or take on any value with specified range or interval. They are associated with the measurements and quantities that can have infinitely many possible values, unlike discrete random variables, which have countable outcomes. Continuous random variables have uncountable outcomes and can take any number within a certain range. Key characteristics and properties of continuous random variables. Uncountable outcomes. Continuous random variables are defined by an uncountably infinite set of possible outcomes. These outcomes are typically represented by a real number within a specific interval or range. For example, the height of a person, the time it takes for a computer program to execute, or temperature in a given location. Probability density function. The behavior of a continuous random variable is described by its probability density function. The PDF specifies the relative likelihood of a variable falling within a particular range of values. Unlike the PMF of discrete random variables, the PDF does not give the probability of observing the specific value. Instead, it provides the probability density at each point along the range of the random variable. Probability distribution. The probability distribution of a continuous random variable is complete description of the probabilities associated with the different ranges or intervals of values. It can be represented by graphically using probability density function plot, which shows the shape and characteristics of a distribution. Probability calculations. With continuous random variables, probabilities are determined by calculating the area under the PDF curve over a specific interval. Probability calculations involve integrating the PDF function over a range of values. For example, to find the probability that a continuous random variable falls within a range, you integrate the PDF over that range. Expected value. The expected value or a mean of a continuous random variable represents the average value it would take if the random variable were repeated many times. It is calculated by integrating the product of each value and its corresponding probability density function. The expected value provides a measure of central tendency for the random variable. Variance and standard deviation. The variance and standard deviation of continuous random variable measure the spread or variability of the variable around its expected values. They are calculated using integrals that involve squared differences between each value and expected value weighted by the probability density function. Continuous random variables are essential in modeling real-world phenomena where measurements can take a wide range of values. They are used in various fields, including physics, engineering, economics, and statistics. By studying the properties and behavior of continuous random variables, statisticians can make predictions, estimate probabilities, and analyze data distributions in continuous settings. Notion and representation of random variable. Random variables are typically represented by capital letters such as X or Y. Discrete random variables are often represented as a list of possible values along their associated probabilities. Continuous random variables are described using probability density functions, PDFs, or cumulative distribution functions, CDFs. Examples illustrating random variables. Example 1. Let's consider a random variable X that represents the number obtained when rolling a paired six-sided die. The possible values of X are 1, 2, 3, 4, 5, 6. Example 2. Suppose we have a random variable Y that represents the time it takes for a customer to complete a transaction at a bank. Y can take on any positive value. Probability distributions. Probability distributions are mathematical functions that describe the probabilities of a different outcomes or events in a random experiment or process. They provide a way to quantify the uncertainty associated with a random variable and determine the likelihood of observing certain values or ranges of values. Probability distributions can be classified into two main types: discrete probability distribution and continuous probability distributions. Discrete probability distributions. Discrete probability distributions are used to model random variables that have a countable set of distinct outcomes. The assigned probabilities to each possible value that the random variable can take. The probability are typically represented by probability mass function PMF, which is this the probabilities of possible outcomes. Examples: Bernoulli distribution models a random variable that can take only two values, usually denoted as 0 and 1, with a fixed probability of success. Binomial distribution models the number of successes in a fixed number of independent Bernoulli trials. Poisson distribution models the number of events occurring in a fixed interval of time or space given a known average rate. Continuous probability distributions. Continuous probability distributions are used to model random variables that can take on any value within a specified range or interval. They are associated with measurements and quantities that can have infinitely many possible values. The probabilities are described by probability density function, which gives the relative likelihood of a random variables falling within a certain range. Examples: normal distribution, often referred as the bell curve, is symmetric and characterized by its mean and standard deviation. Many natural phenomena follow this distribution. Uniform distribution represents equally likely outcomes within a specific range. Exponential distribution models the time between events occurring in a Poisson process. Key properties: range of values. A probability distribution specifies the range of possible values that a random variable can take. Probability assignment. The distribution assigns probabilities or probability densities to each value or range of values. Normalization. The sum of probabilities in a discrete probability distribution or integral of PDF over an entire range in continuous probability distribution is equal to 1. Measures of central tendency. Probability distributions often have measures of central tendency, such as mean or expected value, which represent the average value the random variable would take in repeated trials. Measures of dispersion. Probability distributions may also have measures of dispersion, such as variance and standard deviation, which indicate the spread of variability of random variables values across the mean. Probability distributions are fundamentals in probability theory and statistics. They allow us to model, analyze, and make predictions about the random events and uncertain quantities. By understanding the characteristics and properties of probability distribution, statisticians have derived insights, estimate probabilities, perform statistical inference, and make informed decisions in various fields of study and application. Thank you. We have come to the end of the presentation. Thanks for your time. Have a nice day.